Hi! Today we're going to learn about improper integrals 1. Let's say we have to compute the integral from 0 to 5 of 1 over the square root of 5 minus x. So how do we do this? Well, as you can see, if we plug in 5 into the function, then we get the square root of 0 in the denominator, which is just 0. And so that means that we would have 1 over 0 in the denominator, and we know that you cannot divide by 0. So how do we calculate this integral if we know that we can't divide by 0? Well, when we plug in 5. Well, here's where we go back to something that we learned in the very beginning of calculus. Limits. So we can say that this would be the limit of some value, let's say n, approaching 5, of the integral from 0, and this should be a dx over here, the integral from 0 to n of 1 over the square root of 5 minus x. So now let's solve this integral. Let's do a U-Substitution. Let's substitute 5 minus x for u, meaning that du dx is equal to negative 1, meaning that dx would be equal to du over negative 1, which is just negative du. So this integral would be equal to, or now it's just the limit of from n, as n approaches 5. Oh, and keep in mind that because this is the upper bound, this is as n approaches 5 from the left, and as n approaches 5 from the left, because the integral is a definite integral, so it's over a bound, and this is the upper bound, so we're going from below it to that point, or that bound. So this is the limit as n approaches 5 from below of the integral of from 0 to n of 1 over the square root of u dx. But if we want to compute this in terms of u, or if we want to compute this integral at all like this, then we have to turn this into dx. So we know that dx is just negative du. So this would be times negative du. However, now, because this is in du, or because now this is du, we have to change the bounds to match our integral. So we have to plug in 0 into this equation here. So we get u of 0 is equal to 5 minus 0, which is 5, and u of n is equal to 5 minus n. So this integral would be from 5 to 5 minus n. But hold on, if n is positive, and we know that the limit is approaching positive 5, then that means that this upper limit is smaller than this lower limit here. So what do we do? Well, we know that this would be the integral, and we can erase this. Hopefully you got this part. So we know that this integral is negative because we have this negative sign here. And we know that one of the integral rules says that if we multiply the integral by negative 1, then we can switch the places of the bounds. So this would be the same as multiplied by positive du with 5 minus n in the denominator, or as the lower bound, not the denominator, and 5 as the upper bound. So this looks better. So now let's solve this integral. We know that this would be, we can rewrite the integrand as, instead of 1 over the square root of u, we can write it as u to the negative 1/2 power, negative 1/2 power, and we can apply the inverse power rule to get, this would be the limit as n approaches 5 from below of, so the integral of u to the negative 1/2 power du by applying the inverse power rule would be 2 times u to the positive 1/2 power, or 2 square root of u. So this would be 2 square root of u. and we have this from 5 minus n to 5. So we get this would be equal to the limit as n approaches 5 from the bottom, 5 from below, sorry, of 2 times the square root of u. So here we have this upper bound, so 2 times the square root of 5. So 2 square root of 5 minus 2 square root 5 minus n. Now, as you can see, we can just apply a substitution for the limit and just substitute 5 into this limit to get this would be equal to 2 square root 5 minus 2 times the square root of 5 minus 5, which is just the square root of 0, which is 0. So we get 2 minus 0, which is just 0. So the answer to this problem is 2 square root 5. Today we learned about improper integrals in calculus. Thank you for watching this video.